Hey, welcome back. It's Connecting with Code time. We are ready for our day number 4 of this year's camp. I'm Dave Fisher. I'm at Rolls-Holman. I'll let Bob introduce himself and tell you what we're up to today.
Yeah, Bob Schaefer. I'm out at Mission College in Santa Clara, California. And today we're going to continue our logic games theme with a game called Linear Lights Out. I'm actually really excited about this one. This is a game, one of the only games on this list that I hadn't seen before. Linear Lights Out is played with a sequence of lights, as you can see on the still frame there. And you're going to press buttons. You're going to press each light with the goal of turning all the lights out. Now the trick is, the wrinkle is whenever you press a light, it will turn the opposite of whatever it is. So if it's on, it'll go off. If it's off, it'll go on, as will the lights that are right next to it. So for the middle 5 lights, if you push one of them, that one and the 2 outside of it, all 3 will switch their state. Of course, you might already be thinking ahead. The outer ones are a little different because they only have 1 next to it. So if you push one of those 2 will switch states.
I feel like a evil villain with today's game. It's going to be fun, but it'll torment you some. So I'll get the advantage of getting to actually do a demo for you, just to kind of share a big picture. Rock, scissors, paper, and tic-tac-toe are kind of meant to be 2-player games. NIM's also a 2-player game, but this one actually is a 1-player game, kind of like Coin Collector. Let's show a demo. So got a demo here. We'll bring it up and we'll just kind of show you the idea. So it's a 1-player game. I currently am showing something that I meant to be hiding. That's okay. Let me go ahead and hide that real quick, and then we'll just kind of show it real quick. All right, so the way this game works, the goal is to get all the lights out, as Bob described. The trick is that when you press a light, so if I want to turn off this one, it turns off itself, and then it also toggles its 2 neighbors. And so right now you would think, hey, I'm going to turn them all off by turning this one off. But of course, when you click it, it goes off, but its 2 neighbors come on. So you try to put them out, and you can see that it can get quite frustrating as you try to get it. And so I've almost won the game. I need to turn out these 2, but of course if I click this one, it will turn out those 2, because it always toggles itself and the 2 neighbors. But there I've got, only 1 left. Now if I click that one, it's going to actually toggle itself and its 1 neighbor. It does not wrap around. So somehow you've got to figure out how to get these lights. Aha, I've done it. So as soon as I click this one, I'm going to win, right? Can you see how? So I click this one, it goes out, and its neighbor's going to toggle. So when I click right here, I win. I did it in only 13 moves, right? Now you can play. That's an easy one. Oh, 1 mover, 1 moves. That's fine. You can see that after you win, it just toggles to play again, and you can eventually get pretty good at it. And you can try to impress your friends and family, right? So there's a couple 3 movers there. Great, so this is the game we're going to build. It's going to have a little bit of starting code. This is kind of a hard one. I don't know how to do this one. 7 moves, all right. We're going to give you some starting code, but it's actually a pretty addictive game to play, and it's really fun to get good at it and then make somebody who's not good at it try to play it because you can harass them about how hard it is for them to solve it. All right, that's what we're trying to make. Let's go ahead and look at the starting code. So for this one, we're going to give you some starting code because you don't want to have to make the lights and things from scratch. And so we're going to see what our starting code looks like. And we're going to build just like we did before in small steps. So the starting code will take you to this link here. It's called Linear Lights Out. That's the solution. It's called Linear Lights Out Starting Code. There we go. And you're going to click on this button, Remix. So I'm going to click on Remix. Remixing something means make a copy of it and put it into MySpace. So let's see what we've given you here. So first off, I'm going to rename it. So I'm going to call mine, instead of starting code remix, I'm going to call mine video. You don't have to call it video. You can just call it Linear Lights Out. Let's take a minute and see what the starting code is, and then we'll talk about how are we going to get started, right? So the starting code has 7 sprites. I'll just kind of put Bob and I over the middle here. The 7 sprites are called Light 1, Light 2, Light 3, Light 4, Light 5, and Light 6, and Light 7. You can see that just to keep you focused, we are visibly showing 3 of them.
And then these others are all there. You can see where they're at. They're just currently hidden, just because we don't need to worry about them yet. There's plenty of stuff going on before we even think about those. The code for each one is extremely similar. Whenever it is green flag clicked, it's going to turn the light off. So if I click the green flag right now, it's going to turn them all off. So you can see how they all went black. They all went black because they all have 2 costumes. This is going to be a good thing for you to remember. Costume number 1 is light off. So that's kind of like the first one. So off. And then they can get turned on. So if I click on light 2 here and I switch to this costume, you'll see that it'll come to the on costume. If I hit the green flag again, it'll go back out. So they all switch to the costume light off on startup. And that's it, right? That's all we gave you. so it's going to be exciting, right? There's plenty to do. There's also this variable moves, but nobody does anything with moves yet. There's also a variable we've created for you called light states. Kind of wish I hadn't created this for you, but I did. That's okay. And so light states is a list. You can see that it's got 7 items in it. And these 7 items are how we're going to track the state of the game. Maybe we should look at the solution and just kind of to see how this works. So very similar to what we did with tic-tac-toe, a list can be a good way to kind of like track the state of things. And so you can see that as I played this game, every time I click, it changes the value in the list, right? And so our first goal is really just to get this list to exist and to get this list to be updated properly at a proper time. So if I click here, you can see that it's 1, 1, so off, off, 2, on, off, 1, on, 2, and then off, off. So this thing should always track the state of the game. And then it's this thing that we're actually looking for to see if we win. Because at the moment where they become all 1s, that's when this other sprite, you win, shows up. By the way, this other sprite we have not made for you, so we're going to have to make that. But you can see the moment that you win, there's another sprite that literally just says you win that shows up. Actually, let's just start with making that one. Does that sound good?
Yeah,
right.
You mentioned that you almost wish you hadn't made it yet. Why don't you show everybody really quick how to make it? If this wasn't made for you, this is how you would make it.
So if I didn't make it for you, that would be like, so I click on delete and it just isn't there. The way you make it is you just click on make a list. We actually did this last time. And then I'll call it light states. Now I like the word state because it's like the state of the world, like the variables that saved to keep track of like where you are in your game, like load game. This is the state of the game.
And so in fact, as you get more sophisticated with design, you'll hear the word state used quite frequently. People design state machines and use state variables in more advanced code to just keep track of the state of things. So it's a very common programming word.
Yep. And you can see that this one I chose to use what's called the camel case naming convention, which means it starts with a lowercase letter, no spaces, and then like independent words are capitalized. I just do that for fun. You're going to see that in your coding with this camel case style from time to time. All right, let's go ahead and dive in let's make a new sprite. So we did not make the sprite for you just to get you some more practice with sprite creation. Normally when we make a sprite, we click on this circle. Instead of clicking on it, just do what I did. Just kind of hover over it and let this ribbon pop out the top. So there's different ways to make sprites. You could upload one, like if you've got one from the internet. You could surprise me, just make some random sprite from the library. You could draw it from scratch. This is the one that we want, or that bottom one is to pick up from the library. So I want to paint a new sprite from scratch. When I click on this, you can see that it makes sprite number 1. I'm going to change the name of it to say you win. So it's a sprite, which is just text, which is kind of different. So to make this sprite, you just have to draw it. So I'm going to click on text right here. And then I'm going to click, and I'm just going to write the words, you win, with maybe an exclamation point or 2. I'll do 3. Once you've made it, to make it bigger, you just need to click off of it. I'm going to move Bob and I out of the way some here. You just click off of it, and then you grab a corner, and then you just make it bigger. And then I'm going to also slide it to the bottom here. I'm just going to put it nice and big right in there. If you looked at the one in the solution, it was actually a little extra fancy. You can make yours extra fancy. You can see it had like a black backdrop. That's kind of cool. And so you can do fancy things like that. I think the way that I did it is I just made a copy of it with Control-C, Control-V. And then I made one of them black and sent it to the back. And so that's how I made kind of that drop shadow is what those are called. That's pretty cool. That looks pretty neat. All right, so I made the sprite, which is good. Let's go make some code for it. So take as long as you need. Pause the video. Make your sprite look fun. If it's too big, you can always make it a little smaller. You can change it over here, or you can just change the size right here if you want to make it smaller. Totally flexible on what you want to do. There's no code in here. It's completely empty. But this is kind of like our main game controller. It's kind of like the boss, right? And so when the game starts, go ahead and click on when green flag clicked. The first thing we want to do is we want to hide this thing because it's not going to be visible until later. So I'm going to go ahead and go to looks, and I'm going to go to hide. So when I click the flag, it hides. It's hidden, but it's still very much there, right? It's just not being shown right now. And the first thing that I want to do is I want to prepare these light states. So you can see it's nice and empty right now. To prepare it, I'm going to go into variables. I'm going to make sure that it starts off empty. So I'm going to grab this delete all. You can see that right now with what I did, it is empty. That's because I deleted it manually and then I remade it, and so it got empty. But this will make sure it starts from the same state. And what I want to do is I want to add 7 items to it. So there's 2 ways you can do this. You can say add, and I'm gonna add a 1. You could do this 7 times, right? So if I run it now, you can see that it'll make 2. And it wouldn't take too long to make. I'm up to 4. That's not what we're going to do, right? Bob, what should we do?
What should we do? You want to add more?
Yeah, but I don't want to just add more like a lame-o. What should we do instead of just putting a bunch on here? We need a loop. Got Bob thinking about something else.
Oh, you're talking about doing all of these at once. Yes, of course.
Sorry about picking under there.
Until.
Repeat
number.
67 times. 7 times.
67 times.
67. Cool. And so what this is going to do is this is going to start our light states. And then the buttons are going to toggle them, right? So right now they're all off, and so we're going to eventually scramble the board to start with, right? But right now it's representing the world correctly. So something we're going to have to do is we're going to have to somehow scramble the board. We'll come back to scrambling the board, but I just wanted to make the initial light states here. All right, now let's go to light number 1 and start modifying things. So light number 1. So when light number 1 is clicked, so let's just go ahead and grab the event. When it's clicked, what do we want to happen? So Bob, do you want to describe what kind of things we want to happen when this sprite is clicked?
Yeah, absolutely. If you think about the way that we described the game, we said that whenever the light itself is pressed, we're going to toggle both it and the ones next to it. And so we noticed that with these 7 lights, my fingers can be all the lights, for each one we have to know which one we are and which one is next to us. Turns out I don't know that I can move my pinky without wiggling my ring finger a little bit. That works out quite well for that demonstration. Because those are the 2 we care about. So for this light, we're on light 1. We know that we need to toggle ourselves and toggle light 2.
Yeah.
When we go to the next light over, we're going to have to know that light and the 2 on that side. So we're going to have to do something we've done before in various games, which is a lot of copying and pasting or duplicating, and then adjusting slightly, the numbers to be sprite specific.
Yeah, there's definitely going to be some cranking out there. So this is how programming works. You start by describing what it is you want to do, and then you kind of reflect on the words that you said. And so Bob said all the right words. And so Bob was saying that we need to toggle ourselves. That's actually easy. Don't do this, but I'm just gonna say, if we just wanted to toggle ourselves, we could just say next costume, right? So like every time I'm clicked, I toggle. So that's actually quite easy. I've only done it on night 1 here. That actually, interestingly, doesn't help us enough. You would think that would be all we need, but we need to toggle ourselves and our neighbor. So we need to communicate between us and our neighbor. The way you communicate in Scratch is you broadcast events. So like one person yells something, hey, number 1 got clicked, right? And then various people have to listen to that. So it's interesting that you need to toggle whenever you're clicked or one of your neighbors yells at you. So it's kind of the same thing. So this is what we're going to do. We're going to go into events, and we're going to broadcast that we were just clicked. So I'm going to say I'm going to broadcast click 1. And so I'm just going to scream it, hey, click 1. And people are going to listen for click 1 occurring. And then what we're going to do is when I receive click 1, I'm going to toggle myself, and I'm going to also update this thing over here. So this is kind of sneaky. So I'm going to say next costume. So when I click, I do a broadcast, and I change. You know, like that's the same as what we just did. It's not. Here's why. Light number 2 can also have, when I receive a click 1, I will go to my next costume. So now, whenever I click this, they both toggle, which is kind of cool. All right, there's a little bit more coming. We're not updating the light states. So whenever I click this, it's not updating these light states at all. So I'm going to have to fix that. And so I'm going to have to go into variables. And I'm going to have to modify. I'm going to have to modify item number 1. So it turns out that I'm on light 1 and I want to replace number 1. And the thing I want to replace it with is I want to replace it with either a 1 or a 2. So if I'm a 1, like I'm off, I want to put a 1 there. If I'm on, I want to put a 2 there. Turns out there's a variable already built in that keeps track of the costume number. It's over in looks. I did that very fast, but you can pause me if you need. And then the costume number is going to go right in there. Cool. And so now, if I run it again, you'll see that light number 1 is actually toggling, which is good. Light number 2 is also toggling. And I'm updating over here for just light number 1. So I'm going to get light number 1 kind of finished a little bit more, then I'll come back to light number 2. Another thing that I'd like to do is this you win needs to know when he's won, right? And so somebody's got to warn him, hey, the light's changed. You should check for a win, right? You should see if you should be showing, right? So light number 1 also needs to tell him to check for a win. So here's what we're going to do. We're going to broadcast, and this is for him. We're going to broadcast a new message. We're going to broadcast, we'll just broadcast a message, check for win. Now this is subtle. I'm broadcasting click 1 so that any of the buttons can hear it, myself included, and other buttons can change if they need to. And then I'm broadcasting click for win for this sprite over here. We've got a really unexpected race condition. Bob and I, we worked this out before filming this video, and we were surprised by this. But if you do these two things, like if you broadcast them both like really fast, it turns out that it can check for win before everybody's toggled. So this is really subtle. I didn't see this coming. Bob and I just ran into this bug, and I'm gonna tell you how to fix it now. Notice how there's another broadcast. Here's the other broadcast. You probably don't even know what this thing does. broadcast, click 1, and wait. And so I'm going to just put this back together like that. Ooh, they're almost the same length now. Now, what's different between these two? This one would just fire it off, and then it would just fire the next one off, and then would effectually start at the same time, right? So if you can imagine like two runners in a race, one way to do it is to say, runner number 1, go, runner number 2, go, and then they run basically at the same time. The other way is you could say, runner number 1, go, and you wait for them to finish, and then you say, runner number 2, go, and that's the difference between these two commands. Does that make sense? Bob, did I say that clear enough?
I think so, yeah. And like Dave said, this is something that we discovered. A lot of times when you're writing code, you have a plan, you run it, you go through it, and then you realize something isn't quite right. And it actually can take, a few minutes or even a few hours, depending on how sophisticated the code is, to figure out exactly what's going on. So for these videos, we're recognizing that this is for a beginning audience, and while this problem is somewhat easy to explain, it wasn't necessarily trivial to find, which is why we kind of pre-write the code so we kind of know what's coming. It's similar to the broadcast plan. If you were listening to me describe what we're going to be doing, you might have thought, oh, well, Light 1 can just switch Light 2's costume. But it doesn't have that power. You can only control your own costume. And so this broadcast of I've been clicked and let other sprites decide what to do for themselves is required kind of by the foundation and the limitations of the coding system. So, if you find yourself watching this and wondering, how did they know that? That seems like magic. It's not magic. It was just a matter of us having gone through it before and planning and making sure that we present things in a fairly clear way for you all.
Cool. All right, let's mass produce a little bit. Let's mass produce just for these first 3, and then we'll mass produce all 7. I just want to make sure everything works good. This is just kind of hanging out, for example. I'm going to throw that in trash. Here's what I want to do. I want to put at least this code on all 3 of these first ones. One way you could do it is you could just click on the next one and you could just build it, and that would be fine. There's nothing wrong with that. You can also, this is a fun trick, you can drag it and kind of drop it on the sprite. Notice how it wiggles? When it wiggles, that means you're on the right spot. And what that does is it keeps it in this one, but it also duplicates it. It's kind of like makes a copy of it and puts it in this one. So this is Light number 2. He's going to fire off a new message. He's going to fire off click 2. And then I'm going to copy, drag from nowhere. Then I'm going to copy it onto Light 3. So notice how Light 3 is jiggling here. And all I did is once it jiggled, I just let go of it. And that effectively drops it into here. So you can see that he's got another clear click 2. This guy is button 3 though, so I'm going to put on a click 3. All right, so obviously I need to crank that out for all of them. I will in a little bit. But let me go back to Light 1 and do the other part. So the other part is when I receive click 1, I change myself and I change this little list, right? Light number 1 also needs to have ears and listen for click 2. So I'm going to duplicate this whole chunk of 3. So I'm going to right click right here on the when I. I'm going to say duplicate. And so I actually toggle when I hear a click 1 message, which I would broadcast, or I toggle if I hear a click 2 message. Make sense? And then I'm going to drag one of these onto Light 2. So he kind of wiggled there, so I let go. By the way, you can see that I kind of like started him before. I'm going to actually just throw this one in the trash. So Light number 2, let's think about what he has to do and when he has to do it. So he has to replace item number 2 of the light states, right? So when he gets a click 2, he changes and he replaces this with his value. He actually does that not just for a click 2. I'm going to right click on this and duplicate it. He does that for a click 1. So number 1 is clicked, he'll do it. At number 2, he'll do it. Or a number 3, he'll do that, right? So he toggles whenever he's clicked or either of his neighbors are clicked. It's very clever, I think, and it's neat to see it work. I'm going to do Light number 3, then we'll do some testing. Light number 3 needs this code, so I'm going to just kind of follow my pattern. I'm going to grab one of these, make him wiggle, and then I'm going to change as it appropriate for him. So he's light 3, so he replaces the third item. And he does this whenever he gets information that 2 has toggled. I'm going to duplicate it. He also does this change if he himself is clicked. And then he also does this change if there is a click 4, which we haven't made yet. So I'm just going to say click 4. I'm kind of regretting the message click. I don't know. That's kind of a questionable choice there. All right. So let's test it. So these 3 lights should hopefully work. And work means that they update over here and they toggle themselves. So I've hit the green flag. They should all black out. Super. And that's because they're when green flag clicked. And then when I click this one, it should toggle those 2. Check. I'm going to hit the green flag again just to reset it. When I click the middle one, they should all go 2, 2, 2, light, light, light. Green flag again to reset it. And then when I click this one, it should change 2 and 3. So I click here and it changed 2 and 3. And then 4 is currently invisible. So go through and test yours thoroughly, right? Make sure that that one does that. Make sure the middle one does that. Make sure that this one does that. Once it's working for 1 click, then try 2 clicks because it should turn them on, then right back off. Turn them all on, then right back off. Turn them all on, or those 2 on, then right back off. Cool, and then any combination should also work as well. Great, super fun. Now you're ready to mass produce the rest of it. I will go ahead and do mine in real time, but I'm going to do it as fast as I can. So I'm going to do show all the lights. All right, I've got all the lights up there. And then what I'm going to do is I'm going to take this, when it's clicked, I'm going to drop it on number 4, number 5, number 6, number 7. Then I'm going to come into 4. 4 is going to say, hey, 4 was clicked. 5 is going to have a new message. It's going to say, click 5. I'm doing this extremely fast because it's pure pattern matching, and my hope is that you could do it without even seeing me do it, right? So they all do their clicks. This one is going to be our click 7. Cool. So at this point, they all have this click and wait. So that's done for everybody. Now I'm going to start back in again, and I'm going to do these things on the side. You'll notice that they're going to all follow this pattern of having 3 different things. So 1, 2, and 3 are already done. I'm going to start in on 4, 5, and 6. What I'm going to do is I'm just going to drag one of them onto 4, one of them onto 5, one of them onto 6, one of them onto 7. I put 1 in because now I can duplicate it however I need. Light number 4 should toggle the 4th one. Duplicate, duplicate. It responds to clicks on 3, clicks on 4, clicks on 5. So it responds to 3, 4, 5. Number 5. Number 5 replaces item number 5. Now I can duplicate him 2 more times. He responds to 4, 5, and 6. Bob, you're supposed to be watching me close in case I goof up.
I haven't seen any goofs yet. I've been watching.
I should do something on purpose. This one's going to replace number 6. I can duplicate it 2 more times. And so he's going to respond to 5, 6, and 7. Light number 7 is going to have a slight variation. See if you can kind of think about what the slight variation is going to be. He's going to, of course, replace item number 7 in here. Here's the slight variation. I duplicate him once, and I do not duplicate him again, right? Because he only has to respond to 6 and 7. So you can see the outsides are kind of similar in that they've only got 2 things, and then all the middles are kind of the same because they've got 3. At this point, you should probably test your heart's content. So you can hit play, and it'll black them all out. So if I click any of them, right? So if I click this one, those guys toggle and the light states toggle. Hit the green flag to black it all out again. If I click this one, 2, 2, and 2, on. I can make them go right back off. Cool. You can test as much as you feel like you need. There's no winning or losing right now. But it should do exactly what you expect for every click. And you can do weird combos, right? So if I do that, it's kind of a weird combo. You can do whatever you want to do, right? So
yeah, if it was me and I was trying to do a thorough test, my goal to make sure that really every scenario was handled, and this is probably overkill because of the way that Dave coded it up. He went with the toggle the costume. So we are pretty sure that's going to go with the opposite. But you could click on each one in each state. So I would probably click on 1 and then 1 again. And then I'd click on 2 and 2 again, just to make sure. I'd go 3, 4, 5, 6, and 7. 14 clicks just to make sure that every single time I can confidently turn lights either on from off or off from on, and that it works for every button. Because if you missed even one of those, how about we do this really quick? Everybody close your eyes. Dave's going to change one thing on one sprite to be wrong. He's either going to have forgotten to do a click or changed, what's broadcast or changed a replace item. Okay, open your eyes, and he's going to test, and something's not going to work. He just clicked 1, that looked fine. Just clicked 2, that looked fine. He just clicked 3, and wow, that doesn't look like the ones on either side of 3 are going off. It looks like 1, 2, and 3 are going on and off instead of 2, 3, and 4. So it's like we got to go look at the code and see what one little minor thing Dave might not have, gotten right.
So the goof I chose to make is on my light number 3, I switched it. It actually broadcasted the wrong message. So light 3 is supposed to broadcast click 3. And I had goofed it up just kind of on purpose. But yeah.
Yeah, and when you're doing these duplicates and changing all these things, there was, on the order of like 20 some duplicates and 20 plus edits for the one I receive and all the edits for the item you're replacing. It is not uncommon to miss at least one. Dave's good. He didn't miss any.
I don't like to make mistakes.
This is he's made a lot before, right? That's exactly how you get to the point of not making mistakes. It's because we've made them all. But yeah, you can treat it like a competition. Can I get through this without making any mistakes? I know what I have to do here. And if you miss one, it's fine. That's why you test.
Cool. All right, so our board is working well. I would say the thing that I would like to do next is, first off, I'm going to hide the light states just temporarily. You can always hide it or show it. I just want to hide it for fun. When I hit the green flag, it starts off in a win state. This is actually what you're trying to do to win. So I think before I do anything else, I want to make an algorithm that kind of scrambles the board up, right? So it kind of scrambles it up. There's different ways that you could do scrambling the board up. In this particular game, one of the best ways is to randomly, blindly, just click a whole bunch of buttons as the computer, and then whatever you've got, that's kind of like the starting condition. So that's what we're going to try to do. There are other ways you can do it as well, but I'm just going to tell you that's it works well, and that's what we're going to do. So let's go to where we made these light states, which is the uwin code that we've got over here. Right now, there's very little code in this area, but this is where I want to put the scrambling of the board. So let's talk about how to do that. So what I'd like to do is I'd like to use random numbers. So start off with this. Go to Operators and grab this Pick Random. So what I want to do is I want to pick a random number, 1, 2, 3, 4, 5, 6, or 7, and I want to basically click on that number, right? Which is kind of going to be a fun thing to do. I don't know a really elegant way to do this, so here's what I decided would be good. I really want to have an if statement, and inside that if statement, I would like to broadcast the certain number to click, to click number 1 or something like that. So those are the concepts that I have to coding. So I know what I want to do. I want to randomly click one of them. I know that this code's going to be good. I know that code like this is going to be good. And then the question is, how do I get them together, right? And so really what I want to do is I think I'd like to just set a variable. So I'm going to make a variable here so that I can save this off. And then inside all these others, I'll just say, hey, if that variable is equal to 1, then do a click 1, right? Now, I could put this right in here, but that would work out badly. Because if they all do that, then they'll all independently pick their own numbers. I want to pick one number, 1, 2, 3, 4, 5, 6, or 7, and then I want to check to see if it's a number 1, do this. If it's a number 2, do this. So I'm going to make a new variable. This variable is not a very important variable. I definitely don't want to show it on the screen. I'm going to click on Make a Variable. This variable, by the way, normally we make our variables for all sprites. This one could be either. I don't care which one you pick. It doesn't matter. And this variable could be called anything. I'm just going to call it rand_num because it's a random number, right? So you can call it the letter K. You can call it just the variable X. I'm going to call mine rand_num, and I'm going to use this camel case. So here's what I want to do. I do not want to show it on the screen because I want to use it, but I don't want to set it on the screen. So what I'm going to do is I'm going to set, set rand_num. I'm going to set rand_num to 1, 2, 3, 4, 5, 6, or 7. And then I'm going to check, hey, if rand_num is 1, then do a click 1. I think you can probably guess what I'm about to do here. I'm going to duplicate just the if statement part. And then I'm going to have a 2 do a click 2. And then I'm going to, this is fun, so I'm going to go from 2 up to 4. So I'm going to right click here. And now I've got 4 of them. So this is if it's 3, do a click 3. If my random number is 4, do a click 4. I feel like maybe there should be an easier way to do this, but this is going to get done in no time. You can see that right now I haven't connected it to my code yet because if I put it on here, it'll do it just one time, which isn't so bad. But eventually I want to do it like a bunch. Let me go ahead and finish this. This is kind of being clever. I've currently got 1, 2, 3, 4, so I need 3 more. So check this out. I'm going to duplicate from right here, and then it's going to get me my 3 more, which is going to be just perfect. Stick it on the bottom, and you probably can guess this is going to be 5 for click 5, 6, click 6, or 7, click 7. Great. So I could go ahead and run this code now. What it'll do is it'll randomly click one of them. It's going to be the easiest game to win ever. So I hit play. That time it randomly picked that one. Obviously, if this was my game, all I would have to do to win would be to click it again, and I would win. It doesn't say you win or anything like that yet because we haven't coded yet. Just for fun, I'm going to run it again. Obviously, it picked a 7 that time. There it picked, it looks like 2. That must have been 1, 2, 3. That must have been the 4. Great. Let's go ahead and break this off, and let's just put in a loop. This is what's fun about computers. Once you do it once, you can just put in a loop and do it a whole bunch. I don't care how many you put in here. I'm going to put in 15. If you put in like 50,000, it's going to take a while. So I recommend that you put in a reasonable number. I'm going to put in 15. So I'm going to go ahead and run it again. And you can see, you can kind of watch it, right? So it's flashing because it's doing just like 15 like random moves, which is pretty cool. Great, it's going pretty good. Ooh, that one's actually pretty easy to win. One thing that we could consider, this is like an advanced thing. It's possible. It's not very likely. I'm going to see if it happens here anytime soon. It's possible that you could randomize it, and it randomly makes you in a win state. Does that make sense? If you're concerned about it, I'll show you how to protect against it. But honestly, it's so unlikely that it's probably never going to happen. You can see I've done it many times. It doesn't happen. What do you think, Bob? Should we show them how to protect against that or not worry about it?
Absolutely show it. Yeah.
Okay.
I think the spirit of bringing up a game that you've won before you started is probably something we should have avoided, or something we should avoid. But I remember when we were doing this, we were talking about this, and I think Dave did the same thing he just did for you all, and then it happened. it brought up a win. And he was like, did that actually just happen, or was that like a bug?
I think I was arguing with Bob that we shouldn't bother, and then it happened. I was like, all right, fine.
All right, fine.
Let me show you how we can fix it. So what I'm going to do is I'm going to temporarily break this part off my code. So really what could happen is you could, roll the dice here and you end up with a perfectly solved thing, right?
Everything off.
Everything's off. And one way you could fix that is by adding a repeat until loop. I don't use these that often, but they're kind of fun. So I'm going to add a repeat until loop, and I want to repeat it until these lights contain at least one on light. Let me show you how you can do this. So go to variables. So we're going to repeat it until, here's like the thing I want, until light state contains. Find this light state contains, stick it right up in there. So I'm going to keep on repeating the scrambling until it contains a number 2. So if it doesn't contain anywhere in there, doesn't matter where. And so now I'm going to stick this back in here. And so now it should be impossible to start with a light state of already victory. It's kind of hard to prove that it works, but no matter how many times you try it, even if it does do it, it'll just re-scramble again. The odds of it doing twice in a row are quite bad, but it could. It'll just scramble for longer.
You could probably, you'd have to display something that it was like repeating. Like you could prove it by putting a display message in there that says it repeated, and then probably lower the repeats down to 2 or something, or like a 1 in 7 shot that it's just going to press the same button twice when it sets it up, and then you'd end up in a 1 case. But I think you can just trust us on this one that if you do the code the way that Dave did it, you'll get a scrambled board that is guaranteed not to accidentally end in victory.
Yep. Cool. Let's keep on cruising. So we've actually got a lot done. Let's just kind of review. You click play. It scrambles the board. You can play. It's kind of hard to win, by the way. This is what I was talking about. Like we're being evil because like you have to figure out how to win to test the win condition. It's kind of hard. maybe we could change this repeat to like 1 to help you out. But right now, to test the next level, you're gonna have to like win. Yeah, let's do that. Let's change this 15 to a 1 just for the sake of testing. And so now it should be quite easy for you to win in one move. I'll tell you what, challenge yourself. Do a 2 there. It'll be better for you. So yeah, so there's 1, 2, no problem. And so 1, 2, good deal. All right. Where do we check for wins? Do we remember we had a broadcast that we've been firing for a while now. It's called Broadcast Check for Win, but we haven't listened to it yet. So there's nobody listening. So this you win thing, he should be listening for it. So let's go to events. Let's go to I'm in the you win sprite right now. Let's go to when I receive check for win. So when I receive check for win, I want to actually check to see if the game is won. Somebody needs to increase this moves counter. May as well be me. So I'm going to go ahead and increase the moves first. That's in variables. I'm going to change it by 1. Note that if you're changing it by 1, somebody should also probably reset it to 0. So that should probably be me as well. So I'll tell you what, I'll just reset it to 0. So I'm going to set moves to 0. So notice, oops, I grabbed the wrong one. Set moves to 0. I'll do it just right here. So I chose to put it here. Anywhere in the first part would be fine. But I put it right here because something I'm going to do later. I'm going to actually reset the game. And so I put it right near this repeat until. So just above this repeat until. So now if I click the button, it'll keep track of my moves. So there's 1, there's 2. So you can see it's changing up there. If I play again, 1, and then 2. Great. Let's see if we win. So to see if you win, we need an if statement. And it's kind of like this one, right? So we want to see if it does not contain any on lights. So in a way, it's the reverse of the earlier one. Does that make sense? So before we kept going until it had one, but now we want to check if it doesn't have any. So I want to know, are there no, so I'm going to go to operators and go to not. Takes me a while to get my brain around this. So if there's not any on, and the way we check to see if there's on, we go to variables. We grab this hexagonal one. So if there's not any lights that are on, then we must have won, right? We just won the game, right? So that's how we just won the game. So we want to simply show the you win message. We could also, in our solution, let's run it. Let's see if this works. So if I click that one and then that one, it shows you win, which is cool. Play again. Click that one and then that one. You win. Cool. I like this randomly states too. The other thing that we chose to do in our solution is we told them how many moves it took. That's an optional extra. I'll show you how to do it, but they can see the number of moves right there, right? If you wanted to do that, just like the solution did, so I'll just kind of show you in the solution here. Let's see here. That's the solution. Yeah, so if I show you in the solution, the solution's got a big thing in my way. So let's see here. I'll just go ahead and win one. You see it says 3 moves, kind of like that. If we wanted to do that, we could. That is something you say, which is right here. Now to say the number of moves, you actually need the variable moves plus some words. That is a join statement. Do this kind of fast since it's optional. And I want to join the variable moves with the words space moves, exclamation point, right? If you wanted to say things before, you could. So it says 2 moves. If you wanted to say things before the word moves, you could do that too, but then you need another join statement, like you took, and then like 6 moves or something like that. But it's kind of neat how you can use join to combine like a string with a variable. Great. So this game could be considered done. The only thing that I would like to do is if you look at the solution, this was quite clever. Oh, don't look at the solution like the code. The solution like how it works. The solution would actually, after you play it, oh man, this is going to take me a while. After you play it, it says it for a little bit, and then it restarts a new round. So it's just kind of fun how it just restarts automatically. So let's think about how we could do that, and let's see if we could do that elegantly.
Really quickly, if you didn't do that,
yep.
Is your game in a good end state? If you try to go click on a light, does it let you?
Oh,
or
yes.
Now that you've won, that you've already won before you actually you can win again.
So I win.
Can you keep playing? Does it let you keep going?
It does.
Yeah.
That's a good point.
So I think that's one of the reasons why we decided to do a reset game, because you could either stop everything or reset, and we opted. You know, it's kind of weird to have it say you win and then just have the lights do this weird thing. In fact, if he wins again, I'm guessing it'll say you won, and it'll accumulate. No, from where you are. Yep. I'm guessing that it'll keep checking for win. It'll say it took you 6 moves, even though you couldn't. It doesn't reset the moves count. So that felt like a very unclean ending. So I think that's what motivated our decision to kind of wait a couple seconds and then reset.
Bob and I are sneaky, right? But we didn't like this, and so and you can actually keep clicking even without a green flag click. So yeah, so we decided to reshuffle the board and just start again. Plus, it's an opportunity to learn about functions, right? So what we really want to do is this code right here. I'm going to break it apart right there and zoom in a little bit so you can see where I broke it. So I took this from here and I just kind of set it over there. So this code kind of needs to happen once, right? This creation of the board. And then this code would happen when you start up again. Actually, the word hide should probably be in this area. And so this whole chunk needs to happen to restart a game. So what I want to do is I want to take this reusable code and make a function out of it. A function is also called a block in Scratch. So I'm going to go to blocks. I'm going to make a block, so my own custom block.
And I'm going to call it reset game. And here's how this works. I can take this function and say, hey, whenever you call this function, it's going to do all this code, right? And then since it's a block, I could call it in two places. I can call it from here. So this is when the game first started. And I can call it from here. So this is right after you had a win. And I think that's so neat that instead of writing those like 80 lines of code, it's not quite 80, instead of writing them twice, you just make them a function, and then you just call it in two places. I'll zoom in just so you can see it. So it calls it here, it calls it here, and every time you call it, it runs all that code. Let's try it. So I go boom, boom. It says you win 2 moves, and then it does my shuffle again. You win 2 moves, it does my shuffle again. I think I'm ready to bump that number 2 up. Ooh, that was kind of tricky. Ready to bump that number 2 up to a higher number. So hopefully you're good at 2. And you are also ready to go with 15. And I think we might have a finished game that's way harder. Oh, no. I won eventually. 9 moves. Great. By the way, it just picks which side to put the words on. I didn't set that at all. I'm going to play it a couple more times just to kind of get the strategy. Just to help you out with the strategy, what I do is I usually, I'll just tell you my algorithm. So you can turn this off if you don't want my algorithm. I run all the lights to one side. And the way I run them to one side is I click on the farthest right that will make them go away. So I'll just do that again. So I run them to one side. Actually, this one I can see an easy way to win, so I just would win that one. But I run them to a side, and the way I run them to a side, let's say I'm going to try to run them all to the right. Instead of clicking on itself, which will actually kind of extend that way, I click on the one next to it, and I run them to the side. Sometimes they go away. If I get down to 1, then that's too bad. Sometimes they're all off and you just win. If I get down to 1, what I like to do is I like to turn them all on, which you can always do with 2 clicks. So 1 click, 2 click. And then I click the middle, and then from here it's easy. I do that. So there's my 7 moves, right? So it's not necessarily the fastest, so I just kind of run it over, but it does always work. So I left that one on, so I turn them all on, click on the middle, and then I can win it. So you can kind of see the algorithm that I use. Run it to the side. Ooh, this one I can see I can click right here, and I always win. And then if it happens to be a win, then you won. Great. If it doesn't happen to be a win, I turn them all on, click the middle, and then I win after that. So you can always win quickly. It just may take you more moves.
You know, one of the fun things you can do with this code is because you wrote the code, you can increase the difficulty as you see fit. Now, I think once you get to 15, there's probably a number lower than that. They're mixed up enough. I don't think going to 20 or 30 or 50 makes it any harder. There's like a threshold that once you get to it, it's going to be equally hard. But at the beginning, you noticed when you had it at 2, you just had to find the 2 buttons that were pressed by the algorithm to mix it up. And if you found those 2 clicks, you'd win the game in 2. You could practice by setting it to randomize the board with 3 clicks, and then you'd have to find the 3 clicks that it used to win. And sometimes it's the same click, so you could technically win in 1, or you could win in 3, or if you didn't see it right away, it might take longer. So you might want to, if you want to set yourself up with some practice modes, set that repeat number much lower and see if you can match it in your win total.
Cool. Game's addictively fun.
Yeah, I got 2 random questions for Dave.
Yep.
And
far away.
We might edit this out. Go ahead and hit a green flag for me and reset the game.
Green flag.
Okay. Go ahead and win it.
This is going to be a slower win.
It's a challenge. Make Dave win. He's got the pattern down. All right. All the lights down below are black. And then you reset, and they're all white. Now win it again. Or they're all yellow. Now I'll go black again. When you hit, every time you reset, they don't match right now, but when you click, the icons for the sprites start to eventually match. But I was wondering if you knew what... They don't match now, but they do match now.
That's kind of interesting. So yeah, I mean...
I thought that was just kind of like a random thing. But.
Yeah. No, I'd never been watching them down there because I always play from the other mode, right? It looks like when we do our scramble, it's just too fast for it, just because there's too many things that happen too fast. But whenever we do our clicks, it's slower to where it actually is able to keep up. That's my guess. Cool.
I actually forgot the second thing. It was earlier when you were doing something. Maybe I'll rewatch the video and ask you offline.
All right, make sure you share your project because it's fun. Once you click share, now you've got a URL that you can send to grandparents or whoever would like to see your work. But that's it for our day today. Some of the things that we did is we used a function block, which was really good. We did a lot with broadcasting, with random numbers, repeated loops, all kinds of great things. Some of the take-homes. Bob, you want to take the slide? You can have it.
Yeah, we made really big use of the broadcasting events. I kind of shared earlier as we were talking through motivating why. This was a requirement for this code. If we could control other people's sprites, we might have been able to do this differently, but we had to broadcast events to let the other sprites know when things were happening. And then, as it says in the slide, each sprite then had their own coding responsibilities. They collect information from what's going on, and then they have to have their own logic. We had to write the code for that logic to make sure they did the right thing. And everybody has to do their part. We had an array that tracked the game. It stored our states, a state array. And this is a big problem. If you think about the game of turning on and off 7 lights and having everything coordinated, this was a lot. But as you saw in the span of about an hour, we broke it down into individual thought processes, little problems we had to solve along the way, and it kind of snowballed into eventually a really fun game that Dave can't help himself but play.
Indeed. All right, thanks for joining us. We'll see you next time. We got one more this round. Pretty big game. The game called NIM, or Pick Up Sticks. We'll see you then. Thanks for joining us.
Happy coding.